So today we're going to be solving a LeetCode problem. I'm just starting out in these, so yeah. So let's just pick the third problem. I haven't seen this before, and I'm guessing this would be easy, although it should medium. But let's see. Okay, so we're given a string s, and we have to find the length of the longest substring without repeating characters. Okay, so hmm. So this is the string, and the longest repeating substring, I guess, is ABC. Okay. Yeah, okay, so this is one. I see. I guess this is self-evident. So how can we do this? Hmm. Okay, I guess we just iterate through the array and can have a hash map of sort, or not even a hash map. Yeah, we don't need a hash map. We just need to keep track of a set, and we just keep appending each character to the set. And anytime we encounter a new character, we just check if that is already in the set. If it is, then we okay, what if it is? So let's see this example. So that this is not the longest substring, right? So we can check from B. Substring, I'm guessing is the longest contiguous series of characters. So I don't need to form any combinations. But good with this. Hmm. So if this was D, then this would have been the longest. I see. I see. So actually, we just need to have uh, yeah, we just need to have a start pointer and an end pointer of sort, I guess I don't even need the start pointer. Just need to iterate through the array, and let's see. Yeah, so start pointer is at A, end pointer is at C right now, and we have this in a set somewhere. Now let's say we increment the end pointer, we find out that oh, A is already there. So yeah, this is the length 3 is in the results array currently, and then we move the start pointer one point ahead, and we repeat the same thing. It would find BCA. As soon as it stumbles upon B, it would break input 3 again. It doesn't need to, then on to C, and so on. Let's take something else. Oh, I guess that's all the examples. Hmm. So let's imagine this was D. Okay, let's actually imagine if we had A, B, C, A, C, B, D. Right, so here the longest substring would be 4. So what? So I have a start pointer here, end pointer here. Now I increment the start pointer, and again iterate the end pointer to problem is that might take an n square, right? Not sure. Let's see. That would be n square, worst case. Actually, let's just code that out, and then we can see. I mean, but can we do better? Yeah, actually, I don't need to do n square. I can just iterate through this array once, and okay, I got it. Let's say, okay, sublime is better. We're at A, and so we keep a set of sort where we append A, then we append B, then we append C, right? And I'm just iterating here. So as soon as we hit A again, we check oh it's already there. So we remove what if A was between. Let's say if this was the case, right? I can just remove this. I would need to remove this because yeah, it doesn't really matter. I see. So I need to remove everything from that index onwards. So in this case, that's the first one. So that's cool. And I'll be keeping track of the max length of the set as in when I remove any element. Or basically when I stumble on any duplicates. But okay, so I remove A from here. Now I'm at A again, and it's going on C. So I would remove this. Right. So 3 again. And so this would work fine, but let's actually have an A here. So I'm at A, C, B, and D. I don't need that. I guess this could work. Let's actually code out the solution. Alright. So what do we need? So they're giving us a string. Perfect. We need a max result. So let's say result as, we need to check if the result is greater than this. So let's just have it as 1. Then we need to check if, what do we need? We need a set, right, that keeps track. So let's have a tracker, and we need to have some, okay, the problem is the result should be 1 at the least, because if length of string is less than, well, 1 or less than 2 actually, so result return 1. But what if it's, can it be an empty array? Constraints, okay, 0 is a length of the string, so if it's an empty string, guess I'll just return 0, right? uh, yeah, this works. If, okay, away with the edge cases then. So what was it done for I in sure, let's just iterate for the length. So currently we would have, let's keep a pointer, a start pointer. Okay, so start point is at 0. So now we're just append tracker dot append I as of start pointer to I. So currently it's, well, just that. And we'll just increment. I will increment itself, so we don't need to do anything. However, let's save if, let's say if I in what is that, tracker, then we need to, oh I see, that get function can lead us to trouble. So that get would be off and 2, so this would still be off and square. That sucks. That's okay, I guess. Let's try this. We can get the position of I, and we can just tracker is equal to tracker, right. You know what? Let me just, yeah. Where's the dark mode? I guess Monokai is cool enough. Okay, yeah, sorry for that, I guess. Anyways, what are we doing? Yeah, so far we're just checking uh, if the element is there in the tracker. If it is so, we will remove, well then we'll remove all the elements before that, including that, and we'll append yeah, track the current element to the tracker. So we don't need this, right? We just need to append I. And of course, if that is the case, we need to have length of tracker greater than result to length of tracker. Hmm. Cool. So that works out continuously. But why does it fail? Okay, let's see. Let's check out this one. Yeah, let's just try the solution here. I usually would just test it using the custom console, but this isn't something that we can do. Like, this is not a luxury that we have during the interview. So let's have as the string. This should return ACBD, right? Okay, so this is not true. Okay, let's do this 0 first, and if I in tracker is empty, right? So that's not true. Yeah, so just tracker dot append I. So now tracker is, oh, I'm sorry, it's S of I. Always check your code, kids. S of I. Okay, my bad. And if S of I and tracker. Why iterate through the length? It's a good point. It's a good point. Okay. So, well, in that case, this is A right now, and we have A. Okay, this is B. Is not in tracker, so it just opens up. Now let's see. So okay, so now this is A. This is where it gets fun. So this is true, and which means if length of tracker, what is length of tracker? It's 3 right now. Greater than result. This is true also. So result is now 3. Okay. Tracker dot get I. Guessing this dot get. Yeah, I need to Google this. I can set get index. That is true. That is true. I know that. You know what? That is actually true. So we need to have this as a list. Yeah, that was my mistake. It's dot index, not dot get. So this is what happens when you're a polyglot. Okay, yeah, I know. Okay, so what is this? It would tell me what is index. Tracker dot index of I would give me 0. So pos is 0. This is not true. So tracker would be now 0 plus 1, 1. So it would be BC. And now I would append so BC and A. That's what we want. So this is now C. Right. If I is in tracker, that is true again. Length of tracker is 3, so it doesn't really matter. What is the index of C? It's 1. So length of tracker minus 1. Length of tracker is 3 minus 1, 2, so that's not true. So now this would be actually just C. No, not even C. Just A, right? Because this is 1, so this is just A now. Fantastic. So now we have AC. You can see how this works. AC. And we go on to B. This B in tracker, no it's not, so we just append that. AC. Actually, let me just B. And it's D, which is not in tracker, so I just append that D. But you see the problem. At the last case, we never encountered this, so at the end, we check if length of tracker greater than result. Yep. Result is equal to length of tracker. What if we had A here? Then we'll check for A. We would see, yeah, that is true. Then we'll check the length, which is 4, so that would be true. And register 4, register 0. That's not true. So this would now be CBD and CBDA. In any case, yeah, it doesn't really matter. So I guess this works out fine. Let's just have to return the result. Let's try running this. Not. Guess this is fine. Just try submitting it. Why is it set still? Oh, my bad, my bad. See, faster than 50%. It's okay, I guess. I mean, considering how late I am to the party. Yeah, too much space complexity. Yeah, that is true. So that worked out fine. And I guess, yeah, that's it.